right, everyone, we are going to get started reviewing for our Unit 6 Part 2 quiz review. It's only on the first two lessons for Part 2, so what you did on Monday and Tuesday. So let's go ahead and jump right in. Our first problem, we are going to find the zeros of the equations. Remember, the zeros of the equations are what happen when we set our equation equal to 0. So the first thing we always want to do is take the equation that we're given. So for example, 5x times x minus 8, and we're going to get rid of that y, and we're going to set it equal to 0. From there, I can split it up into two separate equations where each factor is equal to 0. So this is why it's called finding the zeros. So I just go ahead and I split this equation into two new equations, or I just split up the two factors. So I have x minus 8 equals 0, and then I have 5x equals 0. And then I just use inverse operations to find the solutions. So for the first one, I would divide by 5, which really would just leave me with x equals 0, because 0 divided by 5 is just 0. So x is going to equal 0 for my first solution. For my second solution, I am going to add 8 to both sides. So I will get x equals 8. So my solutions are 0 and 8. So when it's given to you, it's super simple. Split it up, set it equal to 0. The second problem we have also is already given us both factors. Super nice of them. So we're just going to get rid of the y and set it equal to 0. And then we're just going to split it up into two equations where each factor equals 0. So we have x minus 5 equals 0, and then we have x plus 1 equals 0. And then we're going to use our inverse operations to solve. So we'll add 5 to both sides. So we get x equals 5, and we will subtract 1 from both sides to get x equals negative 1. So our solutions are 5 and negative 1. Moving right along, in a quadratic equation that has roots of 2 and 5. So roots of 2 and 5 is another way of saying that the zeros are 2 and 5. So for example, I'm saying that x equals 2, and I'm saying that x equals 5. Well, if I wanted to go ahead and figure out what those factors would be, I can kind of do like the inverse operations again so that I can get it equal to 0, right? So I could say x minus 2 equals 0, right? Is that a true statement? If I added 2 to the other side, I would get x equals 2. This one would be x minus 5 equals 0, right? So now I've kind of gone backwards. So now I have my two factors of x minus 2 and x minus 5. I know that a quadratic equation has to have a degree of 2. So now that I have my two factors, stay with me, I need to multiply them to get a quadratic equation. So I need to distribute to get x squared minus 5x minus 2x plus 10. Now I have a quadratic equation. I can combine like terms. I'm going to have x to the power of 2 minus 7x plus 10. And I think they're going to want us to set it equal to 0. So there's our quadratic equation. All right, so start with the roots, work backwards to find the factors, multiply the factors. Which of the following quadratic equations has roots of negative 11 and 7? So which of these would factor to negative 11 and 7? Well, let's see. Negative 11, we're saying that our roots are x equals negative 11 and x equals 7, which would make the factors x plus 11, and x minus 7, right? So that's how we get the opposite answers. When I set those equal to 0, right, I would have to subtract the 7 to move backwards, add the 11 to move backwards. So like if I were to show this, x plus 11 equals 0, well, that would give me x equals negative 11. Okay, so do we see how I'm showing where I'm getting the factors from? I'm just working backwards. Okay, so now that I have the two factors, I can decide which would multiply to equal one of these. So I know that I would get x squared and then I would get minus 7x, then I would get plus 11x, and then I would get minus 77. And then I can combine like terms, so I have x squared, negative 7 plus 11, it's going to be plus 4x minus 77. So which one matches? We have C. All right, so again, work backwards. That's gonna be a lot easier for you than going ahead and just like factoring all of those. You could also do that, but that's just gonna take you a lot more time because you're gonna be breaking it up into 4 different factor boxes. So work backwards, find the factors, multiply them out. All right, it says to solve the quadratic equation. I don't know if you recognize this. I know it's been a while, but that is the difference of two squares, right? X squared and 121 are both perfect squares. And I'm finding the difference between them, right? So the difference of two squares, we have x minus 11, x plus 11, right? This is dots. You might not remember it, so I'll just go ahead and quickly show you the factor box. Again, like I said, we have x squared. That's our A. Our B, however, is not there. B has to have an x on it. So our B is 0. And our C is the negative 121. So you have x times x and 11 times negative 11 to give you 11x minus 11x, right? So that's how we get our two factors of x plus 11, x minus 11. So x plus 11 is my first factor. I'm going to set it equal to 0. I subtract 11 to get x equals negative 11. My second factor is x minus 11. So I get this equal to 0. X equals 11. Okay, so that's how to do it by factoring. And I am sorry that I showed you this extra long way because even I forgot that we could factor by taking square roots. So I'm going to backtrack here. So our answers are 11 and negative 11. Yes, that is true. But I'm going to show you an even quicker way to do it. So solving by square roots is something we often forget, right? I could add 121 to the other side. See, it's like what happens when you get in the mode of factoring, you just can't forget. You get the same answer both ways, but this way is just a lot quicker. I get x squared equals 121, square root both sides. X equals plus or minus 11. So that works as well. You get 11 or negative 11. All right, I'm going to factor this as well by using square roots because both sides, this part that is squared is actually alone. So I'm going to try to take the square root of both sides so that I can get rid of the exponent. When I do that, I get the square root of a negative number, so that's a no solution. You cannot take the square root of a negative number. All right, here we go. Let's try to solve this using square roots. I'm going to add 19 to both sides. And I get x squared equals 81 plus 19 gives us 100. So again, now that my x squared is isolated, the inverse operation of squaring something is to take the square root. So I'm going to square root both sides, and get x equals positive or negative 10. Positive or negative 10. All right, so this is a good example where we cannot just get an answer and make it negative or positive, and I'll show you why. So let's start by adding 12. Our goal is to isolate whatever is squared first. Right, so I'll get x minus 2 squared equals 9. Now that what is squared is alone, I can take the square root. So I will get x minus 2 equals positive or negative 3, okay? So this is what we have to do. You cannot just add 2, make it 5, and then have a negative 5. You actually have to split it up into 2 separate equations because your answers will both be different. So we have the x minus 2 equals 3, right? So when I add 2, I get that x equals 5. That is one of my answers. That is my first solution. But what you cannot do is just say, okay, 5 and negative 5 are the answers. Because when I set x minus 2 equal to negative 3, I get a completely different answer, right? When I add 2, I get x equals negative 1. So please, please, please make sure that you are splitting these up and you are setting up 2 equations to solve for. So we have 5 and negative 1. All right, 24. We cannot solve by square roots because I don't know what the square root of 5x is. So I'm going to start by moving everything to one side so that it's equal to 0. I'm going to do that by subtracting 5x so that I have x squared minus 5x equals 0. Our next step is to always look for a GCF. In this case, I do have a GCF. They both have an x. So if I factor out x, I'll be left with x minus 5. And they both still equal 0. So I'm going to set each factor equal to 0. The first one's super simple because I don't have to use any operations. I just know that x is 0. I'm just going to set it equal. Second one, I have x minus 5 equals 0. I'll add 5 to both sides to get x equals 5. So our solutions are 0 and 5. All right, we're probably going to have to solve this quadratic by factoring. So let's start by subtracting x and adding 4. When I subtract x, I do have a like term right there that I'm going to be able to add it or subtract it from. So we'll have 3x squared. And then if we do negative 7x minus x, we'll get negative 8x. And now we have plus 4 equals 0. Our next step is to check to see if I can GCF anything out. And I can't. So let's set up our factor box. So I have 3x squared. I have 4 and negative 8x. So we're going to have 3x times x. And now we're looking for factors of positive 4 that are going to help us add to negative 8. So I think if we do negative 2 and negative 2, we'll get negative 6x minus 2x. So that does work. All right, so our first factor, x minus 2, set it equal to 0. Don't forget to set it equal to 0. All right, so when I move the 2 over, I get x equals 2. My second factor, 3x minus 2. Set that equal to 0. Start by adding 2. So 3x equals 2, and then divide by 3. So x equals 2 over 3. So we do have a fraction, that's okay. Just make sure your fractions are always simplified. So we have 2, and we have 2 over 3. All right, so 26 is a good example. I can GCF something out. 4, 16, and 48 are all divisible by 4. And when I do this, I just make things a lot easier. It's just easier to put in a factor box. It's easier to solve. The good thing about solving is that even if you don't GCF something out, you will still get the right answer. You'll just have some fractions that you have to simplify, but you will get the right answer. But like I said, it's just way easier to put smaller numbers in a factor box. So we have 4 times x squared plus 4x minus 12 is going to equal 0. So I'm just going to forget about the 4 for now because I'm not asked to find the factors. I'm asked to find the zeros. And 4, if I were to try to take that like I do my other factors and set it equal to 0, well, 4 does not equal 0. So that's really doing nothing for me there. And it is not a true statement. So I'm going to set up my factor box, and I'm going to try to get it looking good. So I got negative 12. I know that 6 minus 2 will equal 4. And 6 minus 2 does equal negative 12, or 6 times negative 2. I'm sorry. So I'm going to start with my first factor, x plus 6. Set it equal to 0. Solve. Subtract 6. X equals negative 6. My second factor, x minus 2. Set it equal to 0. Add 2. X equals 2. So we have negative 6 and 2. All right, looking at 2x squared minus 32 equals 0. I see here that I can solve by taking square roots because I only have one variable, okay? So I only have one x squared in there. So I'm going to start by adding 32 to both sides. Now I get 2x squared equals 32, and I can divide by 2. Now I have x squared equals 16, where I can very clearly see that I can square root both sides to get x equals plus or minus 4, positive or negative 4. So if you really only have one variable and it's a squared variable, your best route is to solve by taking the square roots. It's going to be the easiest for you. All right, this one I do have two variables, so I'm going to move everything to the left so that everything's on one side and set it equal to 0. So I'm going to subtract 9x to get 3x squared minus 9x equals 0. Now let's look for a GCF. They're both divisible by 3x. And when I factor out a 3x, I'm left with x minus 3. Again, they're equal to 0, so I'm going to set each factor equal to 0. And because this one does have a variable on it, I can actually solve it. So it's not like the other one where we only had a 4. 4 doesn't equal 0, but 3x can equal 0, right? Because x can equal 0. 3 times 0 would give us 0. Next one, we have x minus 3 equals 0. So we're going to add 3 to both sides to get x equals 3. So our two solutions are 0 and 3. All right, I got to move everything over again. So let's start by adding 6x. And we're going to subtract 15. So I will have 2x squared. Combining like terms, I will get negative 7 plus 6 will give us negative x. And then we just subtracted 15. So we have minus 15. Let's set up a factor box. We have 2x squared, negative 15, and negative x. So let's do 2x times x. And negative 15. Okay, we can break it up into 15 and 1, but I don't think that's going to help us at all. So we're going to do 3 and 5. Let's see. All right, if we do negative 3, we'll get negative 6x. And if we do 5, we will get 5x, which will still be negative 1. Okay, so our first factor, x minus 3 equals 0. So we're going to add 3 to get x equals 3. Second factor, we're going to have 2x plus 5 equals 0. So we'll start by subtracting 5. So 2x equals negative 5. And then we'll divide by 2 to get x equals negative 5 over 2. All right, we're going to leave it as an improper fraction. Don't forget your negatives. So our two solutions are 3 and negative 5 halves. All right, an auditorium has a floor area of 20,000 square feet. The length of the auditorium is twice its width. So I'm going to start by drawing a picture. It says it's a auditorium floor. It's got a length and a width. So our length is twice the width. So let's say that my width is x. My length is 2x. My area is 20,000. I find area by doing length times width. So if I do 2x times x, I get 2x squared. And I was told that that equals 20,000. So I'm going to solve by taking square roots. Let's divide by 2 to get x squared equals 10,000. And we will take the square root to get x equals plus or minus 100. Okay, so the thing here is I can't have a negative length, right? So I'm not going to have a negative answer. So my one side is just going to equal 100. So if my width was 100 and my length is 2 times that, it's going to be 200. So always use your common sense in these word problems just to double check that like you don't have any negative answers, right? If we're talking about a length, I can't have a negative. If it's time, it can't be negative, all that kind of stuff. We have a width of 100 and a length of 200. There's an extra point here just so that your teacher can give you another point for showing all your work. All right, a ball is dropped from a height of 64 feet. Its height in feet can be modeled by the function h of t is equal to negative 16t squared plus 64, where t is the time in seconds for it's dropped. Find how long it takes for the ball to reach the ground. So if the ball is reaching the ground, that means it has a height of 0, right? If it's on the floor, it does not have a height. So the height is 0. So what I'm going to do is take negative 16t squared plus 64, and I'm going to set it equal to 0. I am finding how long it takes. So I am finding t. That's what I'm searching for. So I'm going to take my equation, set it equal to 0, because right now it's the height after a certain amount of time, and right now the height is 0. So from there, we're just going to solve. I mean, we can solve by taking square roots. We only have one variable. So I'm going to subtract 64. I'm going to get negative 16t squared equals negative 64. And then I'm going to divide by negative 16. Where I will get t squared equals 4. And from there, I will take the square root of both, and that'll give me t equals positive or negative 4. Again, we're talking about time. I cannot have a negative time, so I'm not going to have a negative answer. I'm only going to use my positive answer. So my time is going to be 4 seconds. Sorry, I didn't square root 4, you guys. My bad about that. Okay, so if I square root 4, I will get 2, right? The square root of 4 is 2, so plus or minus 2 seconds. Sorry about that. So I'm only going to use the positive 2, so my time is going to be 2 seconds. All right, that is it for your review. Please make sure if you have any questions that you reach out to your teacher. Good luck on your test.